Hey guys, welcome to Dennis Does Everything. I've got a pair of Prelude gauges here for the 5th gen Prelude, and in my car, the one that I'm taking the gauge out and replacing, I've got a problem that the speedometer needle reads high all the time, and I had to really check this out because I've got transmission problems, and I had to narrow down whether it was coming from the speed sensor or the gauge. I suspected it was the gauge, but I wanted to have proof, and so by creating this test bench setup I was able to do that. What I've got here is I've got a electronic lab kit here. It's got a breadboard, a frequency generator on it and stuff. You could do it with more simple setup, but since I had this available I went ahead and used it. And what I've got here is I've got the speedometer connected to a signal generator. It's just generating a 5-volt waveform and a square wave, and I can turn the frequency up. And as you can see on the replacement speedometer, when it reads about 40 miles an hour, the old one reads 65 or 70. If I go up all the way to say 120, this one maxes out. And if I go all the way down, let's say I go all the way to 0, this one reads 0, while this one still reads 25 miles per hour. I'm not really sure why this one, what is wrong internally with this one on the left, but it's definitely got something up with it. And it always surprises me that when people ask, well, you know, is it possible to test some of these car parts or different electronic parts to bench test them? Well, of course it's possible to test it. You just have to provide power and signal. And what I'm also doing is I'm using a regulated power supply that's in this so that it won't put out more than an amp. So if I get a short, it's not going to put out more than an amp. I'm also using resistors in the circuits before it goes to the gauge input, so that if there were some problem or if I had the wrong pin, then hopefully I wouldn't damage anything. What I did was I got the pin out from the service manual, and on the transmission connector here, which I'll show in a minute, why I've got this set up, I just went ahead and went directly to the pins because I had these nice wire connectors that'll connect to them. But on these ones here, it uses these flat edge connectors. It's a weird circuit board on the back here. It's like a fabric or flexible material rather than a solid circuit board. So I didn't want to try to directly connect anything to it. So what I did was I marked the pins that I needed for power, which is right here, and the ground, and the speed sensor input. And then I went along here and I traced out which, with the this multimeter here, I tested out where they connect. In fact, I can show that right now. So I've got this meter here, and it's going to make a noise, so I'll set it off to the side because we can just use noise. Hear that? And I started with the, for instance, this is where the speed sensor input goes according to the service manual. And I went through and I tested which of these other things it goes to, and I happen to know it goes to this one. And same thing with, for instance, ground. I went and I looked at things that looked like there's a minus here. Is this ground? Well, no, it's a ground, but it's not connected to it. This one's connected to the ground pin. An interesting thing about this gauge cluster is, although all of the power, or most of the power inputs anyway, all come from one line, the grounds are connected separately. I'm not really sure why they did that. Maybe so that it could share a ground with whatever sensor that it's using, or maybe for some other reason. But anyway, so once I did that, I found where the connections actually go, and of course obviously they're right by where the speedometer is on the back here. But I wanted to have that double check to make sure that, just because it seems obvious that this is power, ground, and the speedometer input, I wanted to make sure that, for instance, there wasn't something else in the circuit in between, or that, I didn't misunderstand something. So once I had that, I went ahead and I connected those to 12 volts. And the service manual and the test procedures said that I should measure 5 volts from the speed sensor, so I went ahead and connected this to a 5 volt signal. And then as you can see here, I've still got the speedometer working on these two ones. I probably should have turned the power off before I demonstrated the continuity test, but I already knew which things were going to have continuity, so I wasn't really in any risk of damaging my meter. Anyway, and then the other thing that I wanted to test here is the drive indicator lights. On my old one, when I put the transmission in D4, then I don't get any lights. And that's concerning because D4 is the sport shift mode and so forth. And what's interesting is, and I'll show the schematic that I put on the whiteboard up here in a minute. I can't fit them both in the frame along with this. But what's interesting is the D4 is different from all the other lights in that it's not directly connected to the indicator. It's actually connected through a transistor, which goes to the transmission control computer. The transmission control computer then then reads the switch and decides to light it up or not. And I guess they do that because it's I've heard that it's an indicator light for codes as well with the transmission. And so what I did here was I have a resistor for safety, and I have a switch. Well, this is the resistor for safety on this one. I have it connected to a logic switch, and I don't know if you can see this light here, but when I turn this on, let's see, I don't know if you can see that light up. And as you can see on this one, the D4 light, well, there we go, if I do the right switch, the D4 light comes on and turns off. On this one, no light comes on. And it seems that there's multiple different things that have problems on this gauge. This speedometer is reading high even when it's not even if it's, for instance, even if I disconnect the signal entirely, this one never drops all the way down. And whereas this one goes all the way to 0 as it should. And then, of course, we've got this light that has gone out, and it's different from the others because it has a transistor in the circuit. So it seems like this thing was subjected to some kind of either an overload, overvoltage condition, or maybe somebody disconnected some of the grounds and connected power without some of the grounds, and something, maybe power or ground, went from one circuit through to the other. I don't really know. But at this point, I'm not going to trust anything regarding the gauges in this unit right now. And I'm going to put this one in the car. And just to finish up, I'll go ahead and show what I couldn't show at the beginning of the video. This is the schematic that I drew based off of the service manual. And what I did was first I copied the picture showing where all the connectors were, and very important, I made sure that I knew which end was which in terms of the pin 1 versus the other one, because you can't always just assume that it goes left to right. I forgot to write down that one, but that is actually left to right as you face the back of the gauge. And then down here, this is what I was talking about, that the D4 light is different from the other LEDs on the gauges because it has a transistor in the circuit. And it's actually driven by a complementary transistor inside the transmission control module. So when you put the transmission D4, it actually simply sends a signal to the transmission control module, which then decides to light up the D4 light if it feels like it. And that's different from the other lights, because the other lights are actually direct connections between the switches and the lights. And then up here, this is the pinout for that module. This is where the D4 light actually gets lit up from. That's equivalent to that part right there. there's the 12 volts in and the ground, and then that right there is the brightness control. I was thinking I was going to have to hook up the brightness control possibly, but it seems that I didn't have to for that light. Anyway, that's how you bench test a set of a speedometer gauge and the transmission lights on the 5th gen Prelude. I didn't know how to do this before this morning, but what I did was I studied the service manual, I studied the schematic and the test procedures, and tried to plan out a safe way to test it that wouldn't damage the unit, but would also allow me to test it side by side. And I really like this idea of being able to test two different units side by side with the same setup, because if I had just one of them, and for instance this one was doing this with the speedometer, I might think, well, you know, maybe my input signal isn't right for what it's expecting, or maybe maybe I'm missing a ground connection somewhere, or etc. But because I have both of them connected together and I can see that one's acting differently than the other one for the same inputs, and this one here is acting as I expect it to, that allows me to know that the unit is actually bad. That's different from most troubleshooting procedures for cars that I see written down, or that what you might do in a mechanic shop or whatever, or what I would assume you'd do. I've never worked as a mechanic, I'm an engineer. But what you would normally do is you would just simply replace it, and if the problem went away, you'd conclude that the old unit was bad. But I like to go a step further and actually get the old unit to demonstrate the bad behavior on the bench, and by doing that I can prove that the old unit is not just, that the problem didn't just happen to go away, but that the old unit is doing it. I like to be able to demonstrate a positive rather than a negative. If you do something, you make a change and the problem goes away, that's a negative result, but now you don't really know if you had control over why the problem went away, versus if you do an actual bench test, then you get a solid indication as to whether or not the thing that you changed is actually causing the fix. And then now that I've done this, now I feel a lot better about the transmission change that I've done on the car, because I have a pretty good idea that the speed problems, the speedometer problems, were probably, hopefully not caused by the speed sensor being bad as well, though given that this has evidence, these two unrelated, or seemingly unrelated faults, aside from being both connected to the transmission, given that this is evidence that something electrically bad happened to it, I do probably have to be a little bit suspicious of the speed sensor and of the transmission control module in the car, but at the very least we've knocked out one of the potential problems that was keeping the automatic transmission in that 5th gen Prelude from working. Thanks. Bye.